Okay, this is the last example for 6.2. This is example 5. We're solving a trigonometric equation by squaring. And you'll notice in this one that it also has two trig identities. So I'm going to square this because of the square root 3 that's right here. So I need to get rid of that. And normally when you're trying to get rid of a square root, you would move it, isolate it to one side. But in this case, I can't do that because if I move it over here, it's with the secant. So I'm just going to leave it where it is. And I'm going to square both sides in order to get rid of that. So that gives me, let me rewrite this, tangent x times square root of 3 times tangent x plus square root of 3. Because I'm squaring that, that means to multiply by itself, equals secant squared x. So this I'm going to have to FOIL or distribute. So what they call double distribution. So this times this times this, then that and that. So that's going to be tangent squared x plus tangent square root 3 tan x plus square root 3 tan x. So I'm going to go ahead and add that to square root 3 tan x. And again, my dog, and I just put tax, always feels like she has to be apart. So I don't know what she's barking at. And then square root 3 times square root of 3 is just going to be plus 3 equals secant squared x. Okay, so now I have to deal with the fact that I have secants and tangents in the same problem. But if you remember your Pythagorean identities, secant squared can be replaced with tangent squared x plus 1 because of the Pythagorean identity. Tangent squared x plus 1 equals secant squared. So now I have it in terms of all tangents, which means I need to get all my tangents on one side. So I'm going to subtract tan square x from both sides. And that removes tangent squared x and leaves me 2 square root of 3 of tan x plus 3 equals 1. So now I'm trying to get x by itself. So I'm going to subtract 3 from both sides. So I have 2 square root 3 of tangent x equals negative 2. Trying to get x by itself, so we're going to divide by 2 square root 3. All right, so now I have tangent of x equals, my 2's cancel, and I get negative 1 over the square root of 3. And yes, that you should rationalize that. But there's really no need for me to at this point because I am going to arctangent both sides. So I'm going to take the arctangent of tangent in order to get rid of it. And I'm going to take the arctangent of negative 1 over square root of 3. So remember, tangent is y over x. So I'm looking for where my x value, we're in radians. I know that because of the interval that they gave me. So tangent is where tangent is y over x. And in this case, I need my x value to be square root of 3. So that means I need 3 fingers on top if I'm doing the left-hand trick. So if I fold this finger in, that's going to give me 3 fingers on top. And I just folded in the pi over 6 finger. But I'm looking for where tangent is negative. And in this case, all students take calculus. Tangent is negative in quadrants 2 and 4. So I'm looking for the pi over 6 values that are in quadrants 2 and 4. So if this is pi, that means it's 6 pi over 6. I need to back up 1. So that's going to be 5 pi over 6. And if this is 2 pi, that means it's 12 pi over 6. So I back up 1 and I get 11 pi over 6. And that's it. Those are my 2 answers. So the other thing that's on this notes page is the steps you need to go through when you're solving a trigonometric equation. The first thing you're going to do is decide if it's linear or quadratic in order to figure out what sort of method you're going to use. If it's linear, you just solve for x. Just start, using inverse functions and solve for x or solve for theta, whatever it is you're solving for. If it's quadratic, that means you're probably going to have to factor. If factoring won't work, then that means you might have to use the quadratic formula. So if only one trig function is present, then you just solve the equation for that function. If more than one is present, you want to try to rewrite the equation so that one side equals 0, and then try to use zero factor property. Factor something out if you can. If it's in quadratic form and it doesn't factor, quadratic formula is what you'll use. And then the last the last thing you want to go to, if none of that has worked, is to try to use your trig identities, which is what we did here when we had to get rid of that secant squared. So this is kind of the steps and procedures you need to follow in order to find your solution. So that's it for 6.2. 6.3 is also solving equations. It'll just be a little bit more difficult. So I'll do some videos for that as well.